This is one amino acid, right? And okay, I will make it more. One amino acid, another amino acid, another amino acid. Then one more amino acid, another amino acid, another amino acid. Can you see this thing? That this amino acid is appearing again and again. This is glycine. What is it? Glycine. Actually, the whole alpha chains are having special sequence of amino acid that every third position is glycine. Again, glycine, X and Y position. Is that right? So basic formula of this is glycine, X, Y. And this sequence keep on repeating throughout the thread. It means the nucleotide sequence in DNA, which is coding for glycine, is appearing again and again. Nucleotide sequence, which is coding for glycine, is appearing again and again in DNA. So again appears again and again in RNA. And when the peptide is translated, glycine appears again and again. Right? So every third position, what we have? Glycine, glycine, glycine. You may be thinking, why glycine is there? Do you really want to know, or we just continue our lecture? You want to know it. It's very important. Actually, in future, we'll take 3 chains and twist them. In the future, we'll take 3 chains. You know, this is suppose one chain. This is another chain. This is another chain. And we have to make a triple helix. Actually, on every third position, there should be glycine, glycine, glycine. Glycine is a type of amino acid which has a very small side chain. It is a very, very small side chain. Is that right? Now, when you will twist them tightly, because they have a very, very small side chains, they fit with each other very tightly. You just imagine 3 very smart people hugging each other, or 3 very fat people hugging each other. Where will be really true hug? You have experience, yes. Small people. Yes. What? Smart people or small people? Smart. I mean, if some very fat people with very big amino acids with very big R chain side chains, when they try to come with each other, they just bump around. They don't really, right? So, nature is so wonderfully working. It's not just everything by random. That collagen has to be very tightly twisted. It provides the real strength to our body. If there's no collagen, if I don't have collagen in the skin, I'll just do like this and skin will peel off. Is that right? So because it has to provide the real strength, so nature wanted that when 3 alpha chains twist with each other, they twist tightly. For every third position, nature has put glycine, which is the amino acid with smallest side chain, a very smart amino acid. Is that right? Yeah. This side chain is so close with each other that it's twisted tightly. Now, it has a clinical point with it. What is the clinical point? That there is a disease in which, listen now carefully, there is a disease in which the nucleotide position which code for glycine, that is mutated, that is altered. There is some inherited disease in which the genes are defective. What is the defect in the gene of the collagen? That the point where there should be glycine, that is altered, and the places where glycine should be there, at every third position there should be glycine, isn't it? Every third position there should be glycine. So if due to some reason the point which is coding for glycine is altered, then altered or mutant code may not now code for glycine. Maybe some other bulky amino acids are fit into these positions. And do you think then collagen can really tightly twist? So they will make tight triple helix or loose? And when they will make loose, collagen will gain its strength? And when collagen will not gain its strength, do you think it will be weak or strong? Weak. And in these people, they make their bones. Bones have a lot of collagen. Is that right? Their bones are so weak that even within the uterus of the mother, with the pressure of uterus, the bones of the fetus are crushed. And in very severe cases, there is intrauterine death.
Quick question. You said the reason for that is because of the genes not having a strong...
Look. If you alter this, for example, here is triple C. That is altered into CGC. So it means that point become mutant. So triple C was, let us suppose, coding for glycine, and CGC, which is altered, is coding for some other amino acid which is very heavy side chain. Can it snug properly? No. So collagen will achieve its strength or not?
No. So there'll be like one point out of the chain that's not...
Yeah. Okay. And collagen will be very weak. And if collagen is so drastically weak, right? If so drastically weak, then bones will be very, very weak. And if bones are very weak, some of the some of the fetus, they undergo multiple fractures before even birth of the baby, right? And in some milder cases, babies are born, but baby just fall from the sofa and get ribs fractured and legs fractured and arm fractured. Is that right? That is not Marfan syndrome. That is not Marfan syndrome. You have seen Marfan syndrome, they are tall people, and that is adult onset problem. In this case, do you think bones are made perfectly or imperfectly? So osteogenesis means formation of bones, is imperfect. So disease is called osteogenesis imperfecta. What is the disease called? Osteogenesis imperfecta. Osteogenesis imperfecta. That osteo means bone, genesis means formation. Bone formation is imperfect. Is it right? Because of mutations in the genes coding for the alpha chains, especially for that collagen which is present in the bone. I told you the many types of collagen, right? This type of mutations which lead to this disease, these mutations should be in those alpha chains which are responsible to make collagen for bone. Which type of collagen is present in bone? Yeah, there is so many types of. There are so many types of collagens. Which collagen type is present in bone? Do you know spellings of bone? Do you know spellings of bone? Please tell me. B-O-N. Collagen 1. So when there are such type of mutations in those alpha chains which make the collagen 1, in which chains glycine insertion in nucleotides in the peptide sequence in alpha chain is disturbed, or at many points glycine is replaced by more bulky amino acids, then triple helix cannot be tightened well, and the end result will be very weak collagen. Of course, degree of mutation in different people may be different. Some may have very severe problem if more glycine points are disturbed. Some may have moderate problem. Some may have mild problem. You could not understand. Look, there are multiple genes which make these chains and there are multiple points for glycine. So someone has problem at suppose 5 points. Other person has problem only at 2 points. Another person has problem in 1 point. So who will suffer most? 5 points mutation. And person with, so people may have severe problems, severe type of mutations, or mutations leading to moderate problems or mild problem. It means osteogenesis imperfecta is not one disease, it's a whole group of diseases, it's a whole group of problem, right? For example, someone, product of conception in which these genes have multiple defects and they make very, very weak collagen 1. then fractures will occur within the uterus before the birth, and even skull will be fractured, ribs will be fractured. Do you think brain of the fetus or lungs of the fetus and heart of the fetus can work well? So there will be intrauterine death. That so severe problem is called osteogenesis imperfecta congenita. Yeah, that is fascinating to learn and sad to have. Congenita. Opposite to that, congenita means congenital. Congenital means someone born with a defect. But someone has a moderate problem, right? That baby will be born, the defect is compatible with life, but that baby who is born with osteogenesis imperfecta with moderate problem, with little bit trauma, he gets multiple fractures. That is called osteogenesis tarda. Tarda, right? These type of babies, parents are under big trouble. You know why? Number one, their baby is suffering, of course. That's very easy to understand. That their, for example, mother is holding the baby, right? He just hug him tightly and two ribs are fractured. That's very sad. Right? Baby just fell on the ground and got his femur fractured. This is one problem. Second problem, when parents take these babies to the hospitals, usually hospital people have a, because this condition is rare and child abuse is more common, so hospital doctors, they suspect that probably baby has been battered and beaten. So they call the social service people, and all the time the parents are in trouble to explain that we are not the culprit. Eventually some good doctor will make the diagnosis of osteogenesis imperfecta. And when parents will ask what is this disease, the doctor will say that in simple word we call this disease brittle bone syndrome. Brittle bone syndrome. So what we have done right now, that at molecular level the defected DNA was the mutation or defect in DNA was transcribed into defect into RNA, eventually lead to faulty translation and faulty what? Alpha chains, which could not make a proper triple helix and lead to reduced tensile strength in the collagen fibers, translating into brittle bone disease. Am I clear? No problem.